Good afternoon, and thank you for taking the time to meet today. My name is Erwin Bernales, and I will be presenting the proposed Vulnerability Management Program for Campus Pay. This presentation outlines our current risk exposure, the gaps identified by internal audit, and most importantly, the structured, scalable approach we need to strengthen our security posture. I will also discuss how this program aligns with our strategic direction, including zero trust principles, secure cloud adoption, and the unique risks introduced by our new mobile application, Campus Hire. My goal today is to provide a clear, actionable plan that supports operational integrity and long-term organizational resiliency. On next slide here, I'm going to introduce what we're planning to do. Um, The campus PACE environment has changed significantly in a short period of time. We have moved rapidly into cloud-hosted workloads, expanded our API ecosystem, and launched an externally developed mobile application that connects directly into our AWS backend. At the same time, approximately half of our workforce now works remotely. These employees depend heavily on our VPN and endpoint infrastructure, increasing our exposure to unpatched devices, weak configuration, and credential attacks. During the last audit committee meeting, internal audit reported several unpatched system and critical vulnerabilities, some of which were tied directly to our planned software releases. These findings are not uncommon in fast-growing organizations, but they must be addressed to avoid, business disruption and protect sensitive HR and payroll data. This PowerPoint slide will explain how an enterprise vulnerability management program will reduce our exposure, improve vendor oversight, and move Campus Pay toward a more modern, zero trust aligned architecture. To summarize at pretty much the high level here, the internal audit identified critical vulnerability and outdated system across multiple parts of our environment. This includes our servers, remote endpoints, and cloud resources, and mobile application components. Campus Hire, our mobile application developed by Spectra, has significantly expanded our attack surface. Mobile application introduced risks related to, let's say, SDK vulnerabilities, API calls, um, possible outdated libraries, encryption weaknesses, and unsafe client-side code storage, uh, to say the least. Additionally, the 50% uh, with 50% of our employees working remotely, our VPN and identity system are now first line of defense. Any, vul any vulnerabilities in these areas elevate the risk of credential theft, session hijacking, and possibly unauthorized system access. The solution is a formal vulnerability management program that creates predictable, measurable cycle for discovery, patching, and verification. Incorporating zero trust concept further strengthen our approach by eliminating implicit trust and validating every user device and request. The program objectives, this has seven core. First, they continuously identify and prioritize vulnerabilities across every system, cloud, mobile, APIs, infrastructure, and endpoints. Second point is to protect our most sensitive data. That would be, payroll, benefits, employee records, HR data. These data sets are extremely high value targets for cyber attacks. Third, to enforce clear SLAs for remediation. This prevents vulnerabilities from lingering for months or carrying over into release cycles. Next, to integrate secure development processes into campus Hire's lifecycle. Because it was developed externally, we must ensure Spectra follows secure coding standards. Next, to strengthen third-party oversight, this program gives us formal requirements and exporting expectation for Spectra and any future vendors. Um, this next bullet points also helps us align with compliance, like SOC 2 report, possibly ISO 27001, and any industry best practices out there. These frameworks all require systematic patch management and vulnerability remediation. And last, this program supports our transition to zero trust by ensuring the system that enforce identity and access decision are free of known vulnerabilities. This kind of the analogy of having the protecting the wall around the castle with zero trust. Anybody that was able to establish presence over the wall, we still need to validate the citizen inside that wall. That is what zero trust architecture brings into the program. Program scope, as far as zero trust alignment, this includes our AWS cloud infrastructure, which supports our backend system, API gateway, and data services. It includes our on-prem system and Palo Alto Global Protect VPN. It includes thousands of employee endpoints used both on-site and remotely. The mobile application ecosystem, Campus Hire for iOS and Android, is also included because it interacts directly with our backend APIs. Vulnerabilities in the mobile app can directly impact our production environment. The scope also includes third-party components, particularly code developed by Spectra and mobile distribution channels through the Apple's App Store and Google Play Store. Under the zero trust, the guiding principle is that nothing in this environment is inherently trusted, even if it is inside the network or connected through the VPN. Every access request, API call, and device posture is verified before granting access. The zero trust architecture for Campus Pay. It's not a single product. It is a security model that assumes that the network is already compromised. The goal is to reduce the blast radius and limit lateral movement. For Campus Pay, this means never trust, always verify. Identity-centric access. That means an example will be strong MFA, role-based access. User on VPN are not automatically trusted. Device posture validation, endpoint must be compliant, patched and encrypted, and monitored for before gaining access to sensitive data systems. Micro segmentation, critical system needs to be isolated to minimize exposure. And least privilege and just-in-time access. Admin access is restricted, granted only when needed, reduce the attack opportunities. Continuous monitoring, logs, alerts, telemetry feed into a detection pipeline. Vulnerabilities in these zero trust enforcement points, identity provider, VPN gateway, API gateway, endpoint security agents are treated as critical because they compromise the entire trust model. Vulnerability discovery methods. Our discovery strategy uses both automated and manual methods. Automated scanning includes network scanning through tools like Nessus or Qualys, cloud-native scanning through AWS Inspector, and Security Hub endpoint vulnerability monitoring through our EDR platform. For application security, we use SaaS, SCA, DAS tools integrated into our CI/CD pipeline. This identifies insecure code, outdated dependencies, library vulnerabilities, and API weaknesses. For mobile applications, specialized tools such as AppScan or now SecureTest for insecure storage, API misuse, hard-coded credentials, and transport security issues. Manual discovery methods like penetration testing, code review, and cloud architecture assessments allow us to catch logic vulnerabilities, misconfigurations, insecure roles, and IAM weaknesses that automated scans cannot detect. In alignment with Zero Trust, we give highest priority to vulnerabilities in the system that make access decisions. Here's the risk rating for CVSS business context. We use hybrid model combining CVSS scoring with Campus Pay's business impact. Vulnerability that affects identity, VPN, API, or MFA system is automatically treated as critical because it is compromising zero trust enforcement. This is one of the things that an example in the table right there. That's just potential threat actors. Critical vulnerability must be remediated within 7 days. As you can see in the table, for a high for 14 days for the high, 30 days for medium, and so on. This SLA model ensures we address the most impactful issues first and maintain acceptable level of operational risk. Remediation workflow ensures consistency and accountability. When a vulnerability is discovered, our scanning tools automatically generate a Jira ticket. Each ticket is assigned to the appropriate team based on the asset type, cloud, endpoint, server, application, or mobile. The assigned team performs the fix, whether it's applying a patch, updating a library, fixing a code, or just adjusting a baseline configuration. Before closure, QA performs regression testing to ensure the fix does not introduce new issues or created functionality that is no longer functioning for users. Finally, rescan validates that the vulnerability has been completely eliminated. Only after verification is the ticket closed. This prevents not fake, but false positives and ensures completeness. And mobile app and third-party oversight. Campus Hire Mobile adds a new layer of risk because it is installed on thousands of students and employee mobile devices, and it was developed by an external vendor. We require Spectra to provide a SBOM, software bill of materials, so we can track third-party libraries, identify vulnerabilities related to outdated SDK or cryptographic functions. They must comply with the OWASP Mobile Top 10, and release must pass through SaaS, DAS, and mobile security testing. Any critical or high vulnerabilities must be fixed before the app goes live. Continuous improvement. This program is designed to mature over time. We conduct either monthly, quarterly reviews depending on the needs. We perform annual pen tests to validate our defenses. All that feedback is integrated into the process, ensuring that our alignment with either ISO or both for SOC 2 and meet internal expectation. We also want work to improve our asset inventory because you cannot protect what you cannot see. In conclusion, and some of the recommendation, in closing, the vulnerability management program provides the structure and predictability needed to address our current risk exposure. It will strengthen our security of our, not just for our mobile applications, but also the cloud infrastructure that supports that mobile APIs and other remote endpoints. Also give us a greater visibility into third-party risks, especially from our mobile development vendor Spectra. This program directly supports our transition to zero trust by focusing on identity device validation, micro-segmentation, and least privilege access. With the board's and your approval, we can immediately begin implementation and address the gaps identified by the internal audit. And thank you. I will welcome any questions.